class, I was talking about force, friction, and tension. So I've explained some things on force, and I said everything I've said about force also applies for friction and tension as well. Just that friction and tension have some unique things, some unique features that we need to look into. So today we'll be talking about friction and tension. So let's see what happens to friction. Now, I've already defined friction to be an opposition to motion, an opposition to movement. Friction, as force will tend to cause motion to occur. There is a body that is not moving, force will tend to make it start moving, and a body that is already moving, force will tend to change the way it is moving. I mean, if it's having a uniform velocity, a uniform motion, then force will change the way it has been moving into another form. But friction does the opposite. A body that wants to move, friction will keep it stationary. Friction will not want it to move. That is, if the body is standing on the frictional surface. Now, so if I have a platform, a rough platform. Let's say this platform is rough. Of course, once the platform is rough, then there's friction on this surface. Now, if there's an object on this surface that has mass, the mass m, that's mass m, of course, the normal reaction, which is the weight of the body, is mg, mass times acceleration due to gravity. Now, for every time we have a surface that friction occurs on the surface, there's something we call coefficient of friction. So there will be a coefficient of friction for this surface. Now, we've also derived that frictional force is directly proportional to normal reaction. Frictional force is directly proportional to normal reaction, and our normal reaction is the same thing as mg. Now, this is one of the laws of solid friction. Now, if frictional force is directly proportional to r, now if we have sign of proportionality, if we want to make it an equation, then we introduce a constant. Now, this constant that we introduce here to r is mu. So F frictional force equals to VR, and like I've said, this mu is the coefficient of friction. Now, we can have two forms of friction. We can have static friction and we can have dynamic friction. So this coefficient can either be for static or be for dynamic. And note, coefficient of static friction is always greater than coefficient of dynamic or kinetic friction. Take note of that. Coefficient of static friction is the one that is responsible for a body that has not started moving, and coefficient of kinetic friction is the one that is responsible for a body that is moving already. Now, come to think of it, one of the laws of solid friction states that the frictional force will increase to the same extent as the force that was originally applied. That means if a force is going to cause motion to happen and the friction is existing on the surface between the object and the surface, then the frictional force that will be offered there will be increasing to the same extent as the force that is being applied. Now, I'm coming back to this now. Now, if Fr equals to mu r, now the force required to start a body, to make a body start moving, is quite greater than the force required to keep the body in motion. So that also applies here. That makes the static frictional force greater than the what? Kinetic frictional force. So that's that. Now, continuing with this part, this is just a platform, an horizontal platform. It's not inclined on anything. So we have this to be so. So if I want to apply a force on this mass, let's say the force is force F. Now, no other person is applying an opposite force to this force F, like I've discussed in the case of force. But we know that there will be an opposition to the action of this force. Mind you, friction opposes the action of force. Friction does not oppose force. No, don't ever say the opposite of force is friction. No, friction only opposes its action. So this force wants to cause this mass to accelerate. Of course, if there was no friction and there was nothing, like I've derived the other time, F will be equals to ma. But this acceleration was caused by this entire force, and because no other person has disturbed the motion of this mass due to the application of this force. But if there's frictional force here now, the frictional force will actually alter the acceleration. That is, the acceleration won't be that much as we got from when only this force was acting. Then what will happen in this case? Since the frictional force is opposing the action on this force, then we have something like F minus Fr equals Ma, which implies that the force, and like I've mentioned the other time, this is what? This is the resultant force. Resultant force. So that's the case of an horizontal plane that there is friction on it. Now let's consider another case too. A case whereby we have this plane to be inclined, and of course you can always put this there if we're not given frictional force directly. You can give it the coefficient of friction and you have your normal reaction, then you can insert that here and we'll get that. Now let me move away from this. So we'll go to another surface. Let's say the horizontal surface that we just took into consideration, the horizontal surface was inclined at an angle theta, as in an inclined plane. So if we have this, let's say we have something of this nature, we have this, we have inclined at angle theta, then this body of mass m, of course the weight will be acting downward. This is mg. Now if I decide to draw a line, so this will be my normal reaction, now let's take note of this thing very well. Firstly, this is a rough surface, this is a rough surface. Now this is inclined at an angle theta. Of course, this is a rough surface, and there will be a coefficient of friction there. Now what happens is, if this thing would slide down, normally it can slide down without anybody applying any force on it. But one of the things that will keep this mass from sliding down the inclined plane is that the frictional force on this, if the frictional force on this surface is enough to overpower the weight of this body as it wants to slide down with respect to this angle theta that the body is inclined, then this will not be able to slide down, then it will remain stationary in one position. But if the weight is actually much more greater, that the frictional force cannot hold it back, then the body will slide down. So let me take that into consideration. I will say that that's the first case, a case whereby we want to consider a body sliding down and being counterbalanced by what? By the frictional force. So let's take that into consideration. Now what happened here is, I can always get this angle. This angle is angle theta. Let me show you how. Now you agree with me that from this looks like a triangle. In fact, it looks like a right angle triangle. So if this is right angled, now also from this line of the normal reaction that I've drawn is perpendicular. This line of normal reaction is perpendicular to this surface, which means that this angle 2 is 90 degrees, this angle 2 is 90 degrees. So in the sense that if this is theta, then this one will be 90 minus theta, because the two of them will sum out to be 90 degrees. Now if this is 90 minus theta, then the sum of these two is 90 degrees too. So definitely this place will be theta. For example, if this place was 30, this place will be 60, and this place, the two places sum up to be 90 degrees, so this place will be 30, like that. So for every time we have it, then we can always call this angle here angle made with the weight of the object and the line that gives us the normal reaction. So that will be angle theta as well. So like I said, friction opposes motion, which means that if motion is in this way, then friction will act this way, and if motion is in this way, then the friction will act this way. Now it's not rigid. It's not as if friction cannot act downward, and it's not as if friction cannot act upward. But in this case of sliding down, definitely our frictional force will be up here, so we can have something of this nature. The frictional force will be here, and don't forget the object has the ability of sliding freely on its own, so no force is required to perform the sliding. So here, what do we do now? What I will do is that I will draw my normal reaction. I will draw it as this. You know, that means I've actually rotated this now to be a straight line. So what happens is that this will be, since this normal reaction line is perpendicular to this, then I can draw this now. So this will be like my y-axis, and this will be like my x-axis. Now the next case is that if this is angle, this is our weight, and this is, so the angle that the weight mg is making with the line of the normal reaction, which is this line, and the mg is between, so it's making an angle So we have our mg here. So we have angle theta here. So in this situation, and don't forget I said that our frictional force is acting this way, so we can locate our frictional force in this place. Now we have basically two forces here, the weight mg and the what, and the frictional force. So how do we now balance this force? We can resolve it along the y-axis, and we can resolve it along the what, along the x-axis. Now from what I've discussed about friction, you remember I said that if we have an inclination, we have an angle of inclination for any force, and this our force here is weight. The angle of inclination of this one is theta. But if I'm treating the x-axis now, from what I've said already, the angle theta is not directly between the x-axis and this mg. Instead, it is with the other axis. So, which means that for this case now, I will have mg sine theta. This will be mg sine theta. Now, the frictional force is acting in opposite direction to this side, because by the time you resolve it to this side, then this will tend to be acting in this direction. I mean, this mg sine theta will be acting in this direction. So the frictional force is acting in the opposite direction. So we have mg sine theta minus fr. Then this should equal to ma. But let's say the frictional force was able to keep it steady here, was able to prevent it from sliding. So we have mg sine theta minus fr, that will be equal to 0. Now if that's equal to 0, then what does that imply? That implies that mg sine theta equals fr. Don't forget one thing we said. We said that fr itself equals the weight, equals fr equals mu times normal reaction. So I think it's important for us to get our normal reaction here. What is our normal reaction? Our normal reaction is acting in this. Okay, so this is our normal reaction. That means that we need to take the y-axis into consideration. So let's see what happened along the y-axis. Now along the y-axis, we have two things there. We have the normal reaction and we have this mg too, because this mg will actually have a component with respect to the x-axis, and we also have a component with respect to the what? To the y-axis. So for the y-axis now, so we have r at the top there, so we have r minus, then this is mg. So since the theta is with the y-axis, so we can have what? Minus mg cos theta. Now it will be equal to 0. Why? Because there's actually no movement up or down. The movement we are considering is along the x-axis alone, because this thing is not being lifted up and it's not being pushed down. So this will be equal to 0. So our r equals mg cos theta. So if you put that here now, don't forget, so replacing this now, this will now be mu r, then that means mg sine theta equals mu, what's our r? Normal reaction is mg cos theta. Now, so which means that my coefficient of static friction, now it is static because what? There was no movement. So coefficient of static friction for an inclined plane, inclined at angle theta to the horizontal. Let's see what it will be now. So this is mu equals mg sine theta over mg cos theta. And by the time mg goes out, we have sine theta over cos theta according to trigonometry, that's tan theta. So which means for any inclined plane, any inclined surface, rough surface, the coefficient of static friction for that inclined plane is tan theta. So if you are given a question, you are given the angle of inclination to with the horizontal, then you don't need to bother yourself about running anything up and down. Your coefficient of static friction will be tan theta. So let's pause on friction for now. So when I come back, we'll talk about tension as well.